Hello everyone. So we are back at it again with another Hackerrank in the 1 month preparation kit. And today we are going to look at this problem set called permutating two arrays. Permutating two arrays. So I read through this question so that I don't look too lost during the video. But yeah, this is slightly harder to explain this question. So I'm just going to draw out something to explain the question first, and then I'll get to the question. So they tell us that there are two n element array of integers. So both of these could be quite a long array. If you look down here, they do mention that the n is quite big. So yeah, permutate them into some a prime and b prime such that the relation between a first a whatever index plus b prime the same index should be greater than or equal to k. So in the event there's something like a 0, 1 and a 0, 2, we can rearrange A to 0, 1, 0 and B to 0, 2 such that the summation of the specific indexes would give 1 and 2, which is greater than or equal to K, which is 1. Hence, this is a valid combination, and then you will print out yes. But if it fails that condition, we print out no. That means even after we rearrange and it fails, we print out no. So on first glance, I couldn't really see what is the angle for this question. But then if you think a bit more, you get it that you get that you're basically comparing the best way to get the highest for all, like if you have two arrays of equal size, what is the best way to ensure that the sum of all of them is the same? So the best way is one should be sorted from smallest, so let the biggest, while the other side should be biggest to smallest. That way, you kind of even out any differences that you might have, and all of them will be around the same range. So by having all of them in the same range, the benefit that we get is we ensure that all of them stand a fair chance to be higher than k greater than 1. In the event some of them benefit more than others, I mean, like, let's say if I bump up some section more by not having it in this order, like small, big, and big, small, I would end up having some regions being lopsided. That means maybe the left side has higher values than the right side in general, or the right side has higher values than the left side in general. Like we might run into that kind of issue if it is not in this kind of format, where the small means the biggest and the biggest means the smallest. If we don't have that arrangement, if they don't all stand a fair chance against beating this k value, some sort of beating the k value, we stand no chance of finding a proper algorithm to return the yes and no. So in the end, they just want us to return yes and no. And this is a way for us to get what we want. So coding wise, this is not that complex. This is not that hard, but the understanding and the logic behind it is what is hard. So what I'm going to do now over here is that I'm basically going to make a prime is equal to sorted. In Python, we have this inbuilt sorting function, which is a prime. What am I talking about? A prime is equal to sorted a, and b prime is equal to sorted but reverse. Can I do a reverse? Reverse. Is that all it takes? Okay, I'm not too sure the Python syntax for this. I'm just going to wing it first. If there's any issue later, we will figure it out as it comes along at the later stage. So basically, we now have a prime that is sorted from smallest to biggest and b prime that is sorted from biggest to smallest. And with that, all we need to do is for I in range len ap, if ap I plus bp I is smaller than That means not greater than or equal to. If we are not greater than or equal to k, that means we're smaller than k. K, we return no. And if it manages to go through the whole for loop without returning, that means without breaking the loop, we can return yes. And with that, we should be more or less done with the code. Let me just, I'm a bit skeptical about the, I had no response. What is happening? Sorted expected one argument, but got two. Okay, I'm just going to use the help of Google. In the event of an actual Hackerrank where they are monitoring your screen, don't use Google, but let me just check it out. Sorted reverse. Reverse. Okay, it's just reverse as I thought. Yeah, my bad. This is a pretty basic fundamental mistake. I shouldn't have done it, but yeah. So yeah, we have the test case. The test case passes because previously my syntax is wrong. I was a bit rusty on the syntax and I should have checked it up before I made the video. But yeah, basically I'm reversing using this. So this is the first one. AP is from smallest to biggest, while BP will be from the biggest to smallest. And with that, once we have sorted them into the alternate, like the reverse of each other, if we sum them together, the summation of each indexes AP and BP will stand a fair chance to beat K, and that's what we want. If any one of them fail, we know that we couldn't have had a better chance at beating K than this situation. So if anyone fails, we know that it is a no. So that's why we're able to do this. Now let's just hope I pass all the test cases, which I do. So why did I say that? It's because in the event there are many numbers, we might have an issue with using the sorted function. Like right now, our time complexity, like sorted in Python by default uses quicksort, which is n log n. So we have an n log n over here and another n log n over here, and then we have an n time complexity over here. So this is quite an intense time complex, as in it's a very computationally intense program. But quicksort is the best case to use, unless if it's a really long number, we might have to think a bit more innovatively. On first glance, I can't really think of a solution to combat this, but there might be, maybe, yeah, there might be something that we are not looking at. But yeah, we need to be prepared for that kind of situation where we might need to optimize the algorithm a bit more, etc. So yeah, that is my solution for this Hackerrank, and hope you guys enjoyed the video, and I'll see you guys in the next video. Peace. See you guys.